Budding astronauts can take a virtual space flight to the deepest depths of our galaxy, thanks to a stunning new interactive graphic produced by NASA. The immersive 360 degrees visualization depicts the heart of the Milky Way, roughly 26,000 light-years, 150,000 trillion miles, away from Earth. It was created using data taken by satellites, which capture light that has managed to escape the monster black hole that lies in the middle of our spiral galaxy. Scroll down for video. The project, made using data from NASA's Chandra X-ray Observatory, lets viewers control their own exploration of the fascinating environment of volatile giant stars and powerful gravity around the huge black hole. While humans cannot physically travel there, scientists have been able to study this region by using X-ray, infrared and other observation methods. The visualization also uses infrared data from the European Southern Observatory's Very Large Telescope that found 30 massive stellar giants, called Wolf-Rayet A stars, which orbit within about 1.5 light-years, 8.8 trillion miles, of the galactic center. Powerful winds of gas streaming from the surface of these stars are carrying some of their outer layers into interstellar space. When the outflowing gas collides with emissions from other stars, they produce shock waves, similar to sonic booms, which permeate the area. These shock waves heat the gas to millions of degrees, which causes it to glow in X-ray images. Extensive observations with Chandra have provided critical data about the temperature and distribution of this gas. Astronomers are interested in better understanding what role these Wolf-Rayet A stars play in the cosmic neighborhood at the Milky Way's center. In particular, they would like to know how the stars interact with the supermassive black hole known as Sagittarius A, SGRA. Preeminent yet invisible, SGRA has the mass equivalent to some 4 million suns. In the new visualization, the viewer is at the location of SGRA and is able to see about 20 Wolf-Rayet A stars, which appear as white, twinkling objects, orbiting SGRA as they continuously eject stellar winds, which are shown in a black to red to yellow color scale. These winds collide with each other, and then some of this material spirals towards SGRA. The footage, which starts 350 years in the past, spans 500 years. As the strong gravity of SGRA pulls clumps of material inwards, tidal forces stretch them as they get closer to the black hole. SGRA also impacts its surroundings through occasional outbursts that result in the expulsion of material away from the giant black hole. These outbursts can have the effect of clearing away some of the gas produced by the Wolf-Rayet A winds. Evidence of a black hole at the center of our galaxy was first presented by physicist Karl Jansky in 1931, when he discovered radio waves coming from the region. If scientists are able to successfully image SGRA, the breakthrough would serve as a key test for Einstein's theory of gravity and could cause us to rewrite our understanding of basic physics. According to Einstein's equations, light would be caused by gas and dust accelerating at high speed and being torn apart. This means the black hole might look like a series of gold rings. As I've said before, it's never a good idea to bet against Einstein, but if we did see something that was very different from what we expect, we would have to reassess the theory of gravity. Project leader Shepard Duman from the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts told the BBC. I don't expect that is going to happen, but anything could happen, and that's the beauty of it. Researchers, led by Christopher Russell of the Pontifical Catholic University of Chile, use the new visualization to understand the presence of previously detected X-rays in the shape of a disk that extend about 0.6 light-years, 3.5 trillion miles, outward from SGRA. Their work shows that the amount of X-rays generated by these colliding winds depends on the strength of outbursts powered by SGRA, and also the amount of time that has elapsed since an eruption occurred. Stronger and more recent outbursts result in weaker X-ray emission. The information provided by the visualization and the theoretical modeling led Dr. Russell and his colleagues to determine that SGRA had a relatively powerful outburst that started within the last few centuries. Moreover, their findings suggest the outburst from the supermassive black hole is still affecting the region around SGRA even though it ended about 100 years ago. The X-ray emission is fainter than predicted by the models, for times when the effects of any past outbursts have completely subsided.